Welcome back. In this video we are going to be talking specifically about linear inequalities, and we're going to do so using a single variable. And in order to do that, we need to look at a couple principles that we have that we apply to solving and working with our inequalities. So that first principle here is the addition principle. The addition principle says if one value is less than a second value, then if you add a constant to both sides, you will still have your original value less than its value. Okay, so for example, if I had 3 less than 4, and we know that to be true, if I add a constant to both sides, and notice it is the same constant, so I'm adding 2 to both sides, the question that I'm asking is, will my inequality hold true? And in this case it does. 3 plus 2 is 5, 4 plus 2 is 6. Notice 5 is still less than 6, thus the inequality holds, which is what the principle says. As long as the constant you are adding is the same on either side of your equation, then your inequality sign will hold. Your multiplication principle is slightly different. Here we're starting with the same a less than b, but notice this time I'm going to multiply both sides by a constant, and this constant is greater than 0. In other words, I am multiplying by a positive. So notice it's the same concept as before. I'm using the exact same concept or constant on each side of the equation, and because it's a positive number, it means my inequality will hold in that my a will still be less than b. However, if I multiply by a negative number, so my constant is less than 0, then your inequality will flip. And as you notice here, it changes sides. And in this case, if I start out with a being less than b, multiplying by a negative flips my sign and means now a is greater than b. Okay? So the biggest thing that you have to remember about this is that if you multiply or divide by a negative, then you must flip your sign direction. Okay? So that is kind of the biggest thing that you need to remember. This is what I would consider to be the essential rule when we're dealing with inequalities, is that multiplying or dividing by that negative means that you are flipping the direction sign of your inequality. Okay? Now the other thing that we have here is we have special notation. And that special notation is how you designate or denote the answers that you may have. And so here what you can see is that you are always going to go from your smallest most negative to your largest most positive. And in doing so, you're either going to use parentheses or brackets, or when we say a combination of both, we mean you could start out with a parenthesis and end with a bracket, or you could start with a bracket and end with a parenthesis. Those would be your combinations. Okay? Now, you have to be able to determine what means parenthesis and what means bracket, and in this case, we have a definition for that. So that's these two right here. So first and foremost, if you have an equals to, so less than or equals to, greater than or equals to, then you're going to use the brackets. However, if you don't have equals, so notice here there's no bar under the bottom, then you're going to use parentheses. Now the other piece that you need to note is this piece right here. So plus or minus infinity always ends with parentheses. Okay? Whether you had a greater than and equals to piece in it, doesn't matter. Your infinity sign will always use a parenthesis. So let's look at a couple examples here, just so that we can get an idea of what it is that you generally do. And so here we've got a twofold answer. The first is we need to write our solution using interval notation. And the second says we need to graph the inequality. Okay, so first, let's go ahead and look at the interval notation. Now here, I am looking at all x values that are less than or equal to 3. So this is telling me that 3 is the biggest. So I'm going to start at 3. I've got my equal sign here, so I need to put a bracket around it because that is the biggest. Now if I want all x values that are less than 3, it means I'm going to keep on traveling all the way down to negative infinity, and thus forms my inequality. Now we have to be able to graph it. So graphing inequalities are as simple as you need to draw yourself a number line. So the easiest thing to do is to draw your number line, put in your positive and your negative signs, and then put your 0 in the middle. Once you do that, then you need to look at your equation. So if we pretend that we did not do the interval yet, we're going to look at our equation, we're going to look at what information we have. So here we're using 3. So I would draw in my 3. And I want less than or equal to. So that means I have to do a bracket. So my bracket is going to cut through that 3. And notice I am bracketing my number line. And then I want all x values less than that, so that means I am essentially shading down in that direction, and I'm going to go through my negative infinity, thus showing that I'm including all x values that make that positive. Now take a look at it for just a second. You can see that your interval and your graph match. So using this idea, let's do the second example, but in this example, let's graph it first. So I'm going to go ahead and draw my number line. I'm going to put in my infinities. So here's my negative infinity, here's my positive infinity, and I'm going to go ahead and put my 0 in just so that I have a clear-cut positive and negative side. And now for this one, I am looking at x being greater than 4. So 4 is the number I'm using here, so I'm going to put a 4 down on my graph. And I want values that are greater than 4. So to get values greater than 4, says I'm looking at 4, and greater than means positive, so I'm coming here in the positive direction. And notice I don't have any bars underneath, so this is just simply greater than, which means I'm going to use a parenthesis. So I'm going to open my parenthesis right where that 4 is, and I'm going to shade in this direction, and I'm going to go through that positive infinity sign just to demonstrate and show that we are traveling on forever. Now notice that's just the graph part. So now in order to create the interval, all I'm going to do is I'm just simply going to look at my graph, and I'm going to match my interval to my graph. So my graph starts at 4, so I'm going to start at 4, and my graph used a parenthesis, so my interval is going to use a parenthesis, and it traveled through the positive infinity, so I'm going to draw in my positive infinity and close it off, and thus I have my interval. So my graph matches my interval, and therefore I have finished. Okay? So let's take this idea and let's actually work with how to solve. So solving inequalities says the first thing we need to do is we need to look and see if we have any multiplying or dividing that has to be done. And we need to remember that if you multiply or divide by a negative then you must change the direction of your inequality sign. And then you always need to remember to write your intervals in interval notation and to graph your solution on a number line. Now these are going to be solved in the same way that you would solve a normal linear equation. The only thing that makes it different is we've got the inequality sign. So the first thing I'm going to do is I'm going to look at these and I'm going to look to see, do I have any distributing that needs to be done or anything extra? And in this case I don't. I'm just set and ready, which means I can move my terms back and forth across my inequality sign. So the first thing I want to do is I want to go ahead and keep my x in the positive if I can. So I'm going to take this 3x piece and I'm going to shift it this way across my inequality sign. My 3x is positive, so to move it says I have to subtract. And so I'm going to go ahead and do just that. So subtracting says I'm moving it, so I'm going to have -1, and that's still going to be greater than, and I have 6x minus my 3x plus 5. I still need to get x by itself, so I'm going to take this 5 and I'm going to move it across the inequality sign. My 5 is being added, so to move it again says that I have to subtract. So therefore I'm going to have -1 minus 5 is greater than, and then I have 6x minus 3x gives me a 3x. I need to finish doing the math. -5 minus 1 gives me a -6 is still greater than a 3x. And now at this point I need to divide both sides by my 3. I'm dividing by a positive number, which means my inequality sign stays the same. So this becomes -2 is greater than x. So at this point, once you have kind of solved it, it's your choice. You can either write the interval first and graph it second, or you can graph it first and write the interval second. Personally, I find graphing it first tends to be the easier, as long as you remember that your interval matches your graph. And so I'm going to go ahead and do just that. I'm going to put in my -infinity and my positive infinity, and then I'm going to go ahead and put in my 0. This kind of sets your frame of reference. And then I'm going to look at what I'm doing. Well, here I have a -2, so I'm going to go ahead and set that into my graph. And I'm looking at x being all numbers less than -2. So notice I don't have the equals to, so this is going to be a parenthesis. Because I want less than, my parenthesis is going to open towards my -infinity side. And I'm going to go ahead and shade through my -infinity side, thus creating my inequality graph. Now from this graph, I then very easily can write my notation. Remember, your interval notation should match your inequality graph perfectly. So I'm going to start with my -infinity. I'm going to travel up to -2, and then I'm going to stop. And then in both cases, they are covered with a parenthesis. Okay. So that's the first one, pretty simple. Now what happens if we're given a fraction? Well, we're going to treat the fraction the same way that we would if it was a linear, which means the first thing we need to do is we need to find your least common denominator, or a common denominator, whichever you need. So you need to remember, when trying to find a common denominator, your fallback method is to take any denominators you have, multiply them together, and that number will be common between all 3 or 4 or however many fractions you have. The least common denominator says that you find a denominator that is common between all of them, but it is the absolute smallest. There's a couple different ways, or many ways, that you can go about trying to find it. My favorite way is I like to look at the largest value I have, so it would be my 6 here, and I like to look at then my smallest value that I have, which would be the 3. And the first thing I do is I look at, okay, what is common between my largest and smallest? Well, here the first thing that comes to mind would be a 6. Once you figure out what's common, you look at whatever's left. So does 4 go into 6? Well, that answer is no. So therefore I need to look at something different. So I go back to looking at 6 and 3, and again I'm going to look at what's next in common between 6 and 3. Well, the next logical place to go would be 12. So then, looking at your 4, does 4 go into 12? Well, the answer here would be yes. Therefore, the least common denominator in this case is going to be 12. Once you know that, the easiest thing to do is to multiply your entire equation, so negative 5 over 6 x is less than or equal to 3 over 4 plus 8 over 3x. And then in doing so, you have to multiply all 3 fractions by that 12. So I have, again, 6 or 12 over 6, so we look at how does that reduce. And in this case, 12 over 6 would become a 2. So this is going to be 2 times a negative 5x. I'm still going to input my sign, because notice the 12 right here is a positive. And so here I've got 12 over 4. Well, when we look at that, 12 over 4 reduces to 3. So this is 3 times 3. And then I have 12 over 3, which is going to reduce to 4. So this is then 4 times 8x. And thus I have taken fractions and I have reduced them down to linear terms. So here I have a negative 10x is less than or equal to 9 plus 32x. So I have to solve for x. Okay? So there's a couple different ways that we can do it. We can move the 10 and move the 9, but I've shown examples of doing that. So why don't we take this negative 32 and instead I'm going to move it. Since this is being added, to move it says I have to subtract. So negative 10 minus 32 is going to give me a negative 42x is less than or equal to 9. I need to get x by itself. So in this case, I have to divide both sides by a negative 42. Gives me an x on its own. I'm dividing by a negative, so in this case, this means that I have to flip my sign. So this becomes x is now greater than or equal to, and then I'm going to have negative 9 over 42. And we want to reduce that. So here we're going to have x is greater than or equal to negative 3 over 14. So here I have to be able to write my interval and do my graph. Okay, so I need to turn this so that I can go ahead and draw my graph. So here's going to be my number line. I'm going to go from negative infinity to positive infinity, and I'm going to go ahead and input my 0. And then I have negative 3 over 14. So this is going to come down to the instructor that you have. If you have an instructor like me, all I care about with my students is in general what we're looking at. So what I would tell my students is this is negative 3 over 14. So you would go ahead and go to the correct side and put in your 3 over 14 because we're making sure that you're graphing the way you're supposed to. Other instructors like it to be specific or exact, and if that's the case, then you would want to make sure that you graph your number line exactly how you're asked. Okay. For me personally, so any of my students watching or anyone in general, I just like to see that you have a rough idea of what we're doing, so your fraction or your term is on the correct side of its number line. And then we go ahead and graph it. So here I have greater than or equal to, so that means x is going to be bigger. And the equals to means I use a bracket. So I'm going to plop a bracket into my graph. And then because I don't have anything else, it means I'm going to shade all the way that direction and thus have completed my graph. Now I'm also going to make my inequality interval look like my graph did. So I'm going to start at -3/14, and I'm going to travel up through positive infinity and thus have graphed my term. Okay. So that's an example of a straight linear and an example with the fractions. Both do the exact same thing, and you need to remember, of course, your negative rule. Now, another thing that we do with inequalities is we have what's called compound inequalities. So compound inequalities have two types. First is conjunction. Conjunction is and. So, for example, you might see something like this where you have 5 is less than x plus 2 and x plus 2 is less than 15. The more common way to see it is like this way here, where we see that you have your commonality term that x plus 2 is in the middle, and you have its what are called boundary terms are on either side. And notice in this case your inequality signs face the same direction. Okay. Now we've got a couple ways that we can look at this. Remember, when we're doing it, we can either have bracket, bracket, parenthesis, parenthesis. We can have bracket, parenthesis, or we can have parenthesis, bracket. Those are kind of our 4 different types. So, for example, an and might look like this, where you might have bracket, parenthesis, and you shade in the middle. Okay? So the important thing to remember about ands is that we are going to shade in the middle. Okay? Now, the word or is a little bit more fun. Ors are called disjunctions. What they mean is that we essentially shade the wings. Okay, so again, we might have something that looks like this, where we have 3x is less than -6, or 3x is greater than 2. Now notice these inequalities face in opposite directions. And so what that sets you up at is that you may have something where you have one side here and one side here, and we are shading in the opposite directions here. Okay, so or I like to think of oars of a boat, but anyway, what we're doing is we're called shade in the wings. Okay, that is the or. You're shading on the wings, you're shading on those outermost parts. Now, when you're solving conjunctions, you are not going to be told within the problem whether you had an and or an or. Instead, you have to be able to look at the problem given and decipher based on the equation if you had an and or an or. And then, of course, just like before, you need to write your answers in interval notation and be able to state those solutions on a number line. So let's give this a try. So I have this equation right here, and my problem says to solve the inequality. So notice I have a common term here in the middle. My inequality signs are facing the same direction, and I have two different boundaries on the outside. So the first thing that I would do is I would identify to myself that this is an AND inequality. So for me, if I needed to remember, AND means that I am shading in the middle. Okay, so if you're a big believer in taking notes as you do math, that's one thing that this equation has told you. Now we have to solve the equation. And to solve the equation says I need to get x totally by itself in the center. And right now, it's got partners, okay? Or if you like it, the x is like a candy bar, and you have to unwrap the wrappers in order to get to that candy bar. And so in this case, I have two wrappers that have to go, and so I need to unpack it the same way I would a linear equation. So to get x by itself, the first thing I need to do is subtract 1. Well, whatever I have to do to the middle, I need to do to both sides. So I have to also subtract 1 from this side and subtract 1 from this side. So if I do that, I have 3 individual equations that I am solving or working with. So -3 minus 1 gives me a -4. Since I have not multiplied or divided, my inequality stays the same. On the middle, I have a 5x minus 1, so that leaves behind 5x. On the other side, again, I have not done anything, so my inequality stays the same. And I have 3 minus 1 gives you 2. Now the very last thing that we have to do is we have to divide my middle term by 5. So that means I got to divide by 5 everywhere. So as soon as I do that, I have -4 over 5. Because my 5 was positive, it means my inequality stays the same. 5 over 5 goes away, leaves me with x in the middle. Again, my 5 was positive, so my inequality stays the same, leaves me with 2/5 on the other side. So I have to be able to make my inequality graph and do my interval. So I'm going to go ahead and graph it. Remember, I'm going to put in my negative and my positive infinity, and then I'm going to go ahead and input my 0. I have -4/5 on one side, so I'm going to put that in, so -4/5. And then I have a positive 2/5, so positive 2/5. And I'm going to go ahead and do my graph. Neither one of these have an equals, so both of them are brackets. So I'm going to draw a bracket through my first and a bracket through my second. Notice this is an AND, so my brackets are going to face each other. And I'm going to shade here through the middle. Now in doing so, that means my interval has to match my graph. So I'm going to open a bracket and start with my -4/5. I'm going to travel all the way through until I get to 2/5, and then I'm going to stop. Okay. So that would be an example of an AND. Okay, so in this one, notice we have fractions. So the very first thing that I would do is remove my fractions. And that means I need to find a least common denominator. My least common denominator is what's in common between 3, 6, and 3. So obviously I'm going to look at 6, I'm going to look at 3. What's in common there is 6. Does my other 3 go into it? Well, obviously. So the least common is 6. So I am going to multiply my entire equation by 6 on the outside. So this is 1/3. It's less than 7 over 6 times 3 minus y is less than or equal to 2 over 3, and close. I have to take and I have to multiply all terms by my 6 and reduce. So I have 6 over 3, and that's going to reduce down to 2. So this becomes 2 times 1. My 6 is positive, so my sign stays the same. 6 over 6 becomes 1, so this is 7 times 3 minus y. My sign stays the same. 6 over 3 again is 2 times a 2. And now I need to simplify. 2 times 1 is 2. I need to take this 7, and what I would do with it is I would go ahead and distribute it through. Now a lot of students say, why would you distribute? Why wouldn't you divide it out to get it by itself? And the answer to that is simple. If I divide out by 7, notice neither 2 nor 4 are easily divisible by 7. Therefore gives me fractions, and we don't like fractions. So I would go ahead and multiply it through, because I'm going to have to divide in the end anyway, and I might as well say fraction work for the very last step. And so here, 7 times 3 is 21. 7 times negative y is a negative 7y. My sign stays the same, and here I have 4. Now I need to get y by itself, and I have a linear equation which makes it easy. So the first thing I would do is, again, I would subtract this 21 from all 3 sides. And then in doing so, I'm going to get a negative 19 is less than negative 7y is less than or equal to negative 17. I have to divide all 3 by a negative 7. Okay. So what we need to pay attention to is when I divide, notice I've got this negative sign here that I'm dividing by. The rule says if you divide by a negative, you have to flip your inequality signs. So I'm going to have 19 divided by 7. I have to flip my sign, so my sign changes directions. I get a y in the middle, and then I have to flip my sign again to get 17 over 7. Okay. Now notice y is by itself, so at this point I am ready to go ahead and graph my inequality. So I have negative infinity and positive infinity, and then in this case I'm going to put my 0 kind of closer to the negative side because both of these terms are positive. I then have 17 over 7, and I have 19 over 7. So in this case I have to go ahead and input my terms. So if I look at it here, I'm starting at 17 over 7 and I have an equals. So that means this one has a bracket. My 19 over 7 does not, which means it has a parenthesis, and because it's an and, I shade between. Now to finish it out, I just simply need to write its interval. So I'm going to start with my bracket, which surrounds my 17 over 7. I'm going to input my comma, and I'm going to end at 19 over 7 with my parenthesis. Okay. So here again we had another instance of an and, only this time we had an and that was centered around fractions. Now, lastly, we have an or. How do we know? It says so in the middle. The biggest thing about inequalities, the only time you will use an or inequality is if you physically see the English word or as written in your equation. If you don't see this or, then you have an and. Okay, so that's kind of the biggest hint, tip, trick, cheat that I can give, is that The only time you use an or is if you see the word or. Now, ors mean that you have to solve two different equations simultaneously. So I'm going to start with 3x minus 1 is less than negative 5. And I'm going to go ahead and input my or so that I remember I still have more to do. So doing this, I have to get x by itself. So I have to add 1 to both sides. So I'm going to add 1 to both sides and resolve. So I have 3x is less than negative 4. And then in this case, I have to divide everything by 3. So I'm going to start with x. My 3 is positive, which means my sign stays the same, and this is negative 4/3. Now remember, I had that good old or in the beginning, so I'm going to drop it in at the end. And what that tells me is that I still have another half to do. So I have 3x minus 1 is greater than 5. Again, I need to solve. So I have to add 1 to both sides. This becomes 3x is greater than 6. I need to divide everything by 3. This becomes an x. Because my 3 is positive, my sign stays the same, and 6/3 is a 2. Once you do that, we now have to state our answer. So first thing I would do is go ahead and draw your number line. This is the negative infinity, this is the positive. Here's my 0. I have negative 4/3, so I'll drop that in, and I have a positive 2, so I'll drop that in. For my first one, I'm looking at all x values that are less than negative 4/3. So less than says parenthesis. So I'm going to open my parenthesis, but it's going to face my negative infinity, and I am going to draw through my negative infinity sign. I then have the other side. And so here I'm going to start at 2, and notice I'm looking at all values greater than it. So I'm going to open a parenthesis towards that side, and I'm going to draw through my positive infinity. Now, just like with everything else, I need to make my interval match my graph. So ors are done a little bit differently. We're going to start with the first part. So we have starting at negative infinity, traveling all the way through negative 4/3, and then we have to close it off. Now we need to represent this vacant middle space, and we do that by using a U. And then I have to do the other side. So then we're going to open it back up at 2, travel through the positive infinity, and close it. Okay. And so that is your look at what your OR inequality would look like. Okay. So if you have any questions, please let me know. Otherwise, we'll see you next time.